Hi, guys. So, welcome back. Another lineup of amazing speakers. So, Sarah set such a good momentum for this morning, and I'm pumped. And it could be because of that, or also because of my copious amounts of caffeine this morning. So, either way, allow me to introduce our amazing speakers. We have Cameron Balmer and Daniel O'Sullivan. Cameron Balmer is an XR application developer at Sentireal Belfast. Has graduated with a first class honours in computer games development from Ulster. He has previous industrial experience and works within a technical team to produce a variety of immersive applications for clients. Cameron is also currently studying for a master's degree in applied cybersecurity at Queens University. But okay, Cameron, come on, man, just come through with your expertise. It's okay, but like, give the rest of us a chance, you know? Cameron will also be joined by his colleague Daniel O'Sullivan. Daniel joined Sentireal in 2018 in the role of mixed reality application developer. That's a mouthful. And has since graduated to the role of senior developer. Okay, talk about your glow up. We see you. He studied computing with games development at Ulster University, graduating with a first class honours degree. His area of expertise is virtual reality development using Unity Games Engine. Guys, I'm going to hand it over to yourselves. Wow, go on.
Thanks very much. I'll do a wee screen share here, and we've got a PowerPoint for you today, so let me just see if I can get that working. Okay, I think that's it there. Yeah, so our talk today is about the benefits of training through immersive realities. We've already got our wee introduction there, but yeah, my name's Daniel. I joined in 2018 this company, Sentireal, that we're working for now. Studied up in Coleraine, which was a really nice university. I really liked it up there. Mostly I work with virtual reality, and mostly I use the Unity game engine. Do other things as well at the company, you know, but virtual reality is kind of like my main thing. It's my favorite. I'll go over to Cameron here now.
Yeah, so I'm Cameron. I'll not blab on about myself too much more here, but just the same as Daniel, I mainly work with virtual reality within Unity Games Engine. I joined the company in August 2020 there, and I'm a recent graduate from Ulster University's McGee campus, where I studied computer games development. And since joining the company, I've worked on a wealth of immersive applications, some of which you'll be seeing today.
Cameron, do you just want to tell me next whenever you're ready for me to move on there?
Yeah. So just to give you a bit of background on the company, Sentireal was founded in Belfast in December of 2013 with the main aim of creating improved educational training and assistive software by harnessing the capabilities of emerging technologies such as VR, AR, and AI. The company has grown steadily since then to include a senior management team and a technical team of developers and designers like ourselves. We were named as one of Boov's top picks for European corporate training companies and one of the top training and top virtual reality companies in the UK by Whelp. Next, Dan. So the company's products and services, what do? We have our immersive software platform, which facilitates personalized learning using VR and AR technology, and this is currently in development. And we also develop more bespoke educational training and assistive software apps using VR and AR technologies. And again, you'll be seeing some of these later on. We operate in the medical, healthcare, manufacturing, construction, education, and tourism markets. And our clients represent those from both the private and public sectors on a local, national, and international scale. Next, Dan. So augmented reality, what is it? Augmented reality is the realistic integration of digital information into our real-world environment. It creates an engaging and interactive digital experience, which is then overlaid onto real-world objects. So naturally, it lends itself quite well for educational use. It's the more accessible of the two XR mediums, as mobile devices can be used to display AR content. However, there is dedicated pieces of hardware out there, for example, the HoloLens as well. I guess the most popular example in popular culture would be Pokemon Go. It utilizes this technology. And some examples of Sentireal products that use the technology include our monastic habits and/or pathology apps, plus a lot more. Virtual reality, VR is viewed using VR headsets, which allow users to become totally immersed and engaged in the learning experience. VR provides accessible, risk-free learning situations with the opportunity to try and retry without the fear of failure or the consequences that may arise from this. It allows learners to place themselves in different virtual environments, freeing them from learning only at dedicated training centres. And some examples of Sentireal products that use this technology include Body Blaster 2059 and our construction training and housing inspection apps, which you'll be seeing today. Next. So artificial intelligence. Artificial intelligence refers to any human-like intelligence exhibited by a computer, robot, or other machine. Our AI technology allows the training content that we're developing to be continuously adapted to reflect the needs of each individual learner, and also allows for continuous background assessment as they participate in the training.
Thanks very much, Cameron. Yes, so Sentireal, why we do it. I think these are some good examples here. So who here learned how to drive a car by reading a book? Nobody, probably, hopefully. Do you learn how to ride a bike or fly a plane from having it dictated to you? You definitely don't. Could you read a book to learn how to play golf? No, we learn by doing. So we're practical creatures. We need to get out there and do things rather than learn about it through reading, which is boring. Sentireal, why we do it again. So this is kind of talking about homework as another example. We used to do it all the time in school, but we could do it for practical things like maths, because you can practically do maths on a piece of paper, but you can't really practically fly a plane on a piece of paper. It's not really the same thing. Sooner or later, we're going to have to get out there and start doing things rather than just reading about it. No matter what you're doing and no matter what you're studying, you're going to have to get out there and practically do it rather than just reading about it. There's that step that naturally has to happen. Another benefit as well is the safe, risk-free training. So it's really good because XR training, it can offer an environment where you can't get hurt. So think flight simulator. If you crash a plane in real life, it's probably going to be bad, but if you do it in Microsoft Flight Simulator, you don't really lose that much. It's just a bit annoying sometimes. So, yeah. Another cool thing about it is overlays, which we can use for training. It kind of combines the best of both, because it takes the sort of stuff that you'd find in a textbook and then it overlays it like on the job. We actually we created an app for this once where it was training people how to make coffee. So it was using an augmented reality on an iPad or a tablet or something, and you would hold it up and it would overlay the controls onto the coffee machine, like, plug in the thing here and turn it here and press for the hot water and do all that kind of thing. So it was really useful because it sort of combines those two things. Another benefit as well is knowledge retention. So traditional training through textbooks and stuff like that, you only really retain 20% of the knowledge that you read about in that, whereas practically doing it, you retain about 90% of that knowledge, and that's a big, massive step. So that's a big benefit. And a good example of that actually is the event organizers. They gave us out a handbook on how to use the software, where it went through it step by step, where you read about it and do it. But on top of that, they knew we were going to need something physical. So they actually took us aside and gave us everyone a one-on-one sort of information on how to go through it and use the software ourselves, which is obviously kind of where we learned the most on how to use this hop-in software. So today we're going to kind of go over some of the examples of our work and how the examples of what we've done really tie in to these examples of benefits of XR training. So the ones there in larger were the ones we're going to talk about today: the training room ophthalmology, premises inspection, and construction site training. We have done a lot more apps, but these are the ones that me and Cameron have both personally worked on, and the ones we like talking about the most because we find them the most interesting. So Cameron, I'll hand it over to you here for the next bit.
Yeah, so the first application we're going to talk about here is Training Room. So Training Room is a product that we're currently working on to deliver conventional 2D training videos in a VR environment. One of the added benefits of the ability to do this and provide it in a VR environment is the lack of distractions. So I don't know about you, but the amount of times whenever I was sitting in lectures in uni or online lectures now, and I'd find myself ending up on my phone or maybe if you're watching it online, you end up on the Steam Marketplace or ASOS or something, 20 minutes into it, and you kind of zone out. VR prevents that. It keeps learners totally engaged and immersed in the experience. So the application has a built-in testing system, which allows the system to quiz users and allow them to answer questions on the training videos that they've just watched. And this is all managed by a web portal on the back end, where the trainer and administrator can delegate specific videos and set up questions for users. Next. So this is a demonstration video of Training Room. So if you go ahead and click play there, Daniel. So this is the Training Room environment here. And you can see once we go in here, it's just asking you to enter your credentials, which you'll log in. And obviously, once you enter your credentials and log in, you'll be able to access the material that your administrator wants you to see. And this is just a really early version of the UI, just to sort of get the point across. But you can see here, health and safety. Watch the video. You can see the video being displayed there on the TV in the background. The idea is this would be some sort of health and safety training, or any sort of training really. And then you can then take a test or quiz based on that. We can expand on this a bit further as well. There's a door located just to the left there. You'll probably see the little blue, it says underwater on it, just in the left there. This actually, we can allow you to sort of use this as a pathway to a full VR experience once you go through this door. However, it's just trying to introduce people gradually to the concept of VR. If you throw someone into an experience like this, where they're just sitting watching a TV, it's probably not going to be as sort of jarring for someone that's new to the medium than if we threw them into a full-scale construction site with pieces of equipment moving about. Next slide, Dan. So the technology that's involved in its creation. So most of the front-end VR applications we create are built within the Unity platform, which me and Dan have already mentioned. That's sort of our area of expertise. We utilize the virtual reality toolkit, or VRTK plugins, for a lot of our development, as this kind of gives us a good starting point to build off of and continue on with our application from there. And we make considerations on an app-by-app basis for things like movement schemes and how we interact with objects. It's really to try and reduce motion sickness as much as possible. But as I say, it's something we do on an app-by-app basis. Next.
Yeah, so this is back to me again. Thanks very much, Cameron. So yeah, another example is learning on the job is a big benefit that you get from immersive reality training, and we're going to kind of show that off today by talking about this project that we did, which is the ophthalmology project. So ophthalmology is the study of eye disorders. There's a whole bunch of different ones, like relative, got them written down here, relative afferent pupil disorder, acute angle closure, glaucoma. It's really hard stuff, but I mean, I've worked on it, so I probably should know it by this point. But it's actually for Queens University. We made the app for them, and it's to help their students train. Because the way they currently train at the minute, they currently have to have a real patient. So the students would have to go out to where there's a real patient, or the patient would come in or whatever. And they'd actually have to go and physically see them. But as you can imagine, with COVID-19, that kind of creates a bit of a problem, because there's so many restrictions in place, they can't exactly do that anymore. But even without COVID-19, there were still some issues with this method of training. Like a lot of the rare conditions that you might not see present as often in people all the time, they wouldn't get as much practical experience with that. They wouldn't see those conditions as much, so they wouldn't have as much practical knowledge on those conditions. And as well as that, say the students just fancy going and practicing and doing something, revising for a test, they have to make sure there's a patient there, and they might have to wait their turn in line with a whole bunch of other students before they get to, have a go and do all the tests and stuff like that. So there are still a few issues with the way that they currently train. So our solution to this is we built a virtual reality simulation of the entire process of how a student would go in and grade a patient and see a patient and run the tests on them. So our application, it simulates a whole bunch of different eye conditions from the ones that are very common to some of the rare ones. And this is an app that can also be expanded on too. We can add in a whole bunch more different conditions if we feel like it, which you can already see the benefits there, I'm sure. This app that we created, it records their actions throughout the whole thing. So even before they start shining the torch in the patient's eye, it records, did they sanitize their hands? Did they turn the light off? Did they greet the patient? Did they ask them for consent to do these tests? All that stuff. Then the student will go over to the virtual patient. They'll conduct the exam. They'll grab a pencil, move it back and forth, make sure their eyes are following it properly, making sure their eyes turn in. Then they'll take the pen, do the swing test, shine the torch in their eyes, just have a look and make sure their eyes are all responding correctly. Then when they're happy enough, they've got all the information they want from like shining the torch in the patient's eyes and doing their whole thing. You can go over to the desk bed that you can see in the picture, and there's a button that comes up saying end examination. They hit that and it takes them to a quiz. And then that quiz will ask them a whole bunch of different questions about did you notice anything with their left eye? Did you notice anything when you were doing the swinging test? Did they respond correctly to whenever you're moving the pencil back and forth? And at the end of that wee quiz, they'll be asked for a diagnosis. So then the student has to diagnose the patient and say what they think is the condition, if they have it. Sometimes it's normal, sometimes they don't have any condition. And then once they've diagnosed them, they get the results back. So you get immediate feedback with a feedback sheet, and it tells you not only how well you did in the wee examination quiz at the end, if you got the right diagnosis and everything, but if you did all the preceding steps in the right order. Like, did you remember to sanitize your hands first? Was that the first thing that you did because it should have been? Did you remember to turn the light off, which is a big one? Did you remember to greet them? All that kind of stuff. So it's really good in that way because it gives them immediate feedback. I've got a wee video here as well of the application running, so I'll show it here now. You can see there's me picking up a pencil and moving it back and forth. So you can see your eyes following it and turning in. Then the torch shining in her eyes. It's quite difficult to see here because you're looking at it through a 2D screen, but when you're in virtual reality, it's a lot better. But if you look at her left eye, or the eye on the left, sorry, you can just about see it contract whenever the torch is showing in it. Might not be able, it's very, very difficult to see here, but when you're light up in her face, it's something that you notice. But it's all very, very subtle, so finding them is quite difficult. You really have to be good at it. So there's the swing test going back and forth between the two different eyes. And yeah, that's just sort of a wee basic outline of how it works. And then after they were done with that and they've got all the info they wanted, they hit examination and fill out the quiz and all that. So this is the interesting part, I think, anyway, the tech that was used in its creation. So this is sort of what we were doing mostly. It was all pretty basic tech as far as tech goes, really, that we used. There was nothing too drastic. We had our 3D artist in-house. They created the character and animated them up or her up and everything. Gave her some idle animations so she didn't look completely stiff. The eyes, the way that the eyes open and close, the pupils, you can see in the picture there, one's open and one's closed, dilated and contracted. We use blend shapes, something called blend shapes, where you can slide in and out on a scale between open and closed. And then we actually linked in with some third-party software as well, which sped up the development process quite a bit. That third-party software allowed us to do things like blinking animations, then just fault tracking and stuff that would be quite basic, but you would also see in a lot of games. That's why it's kind of out there and available. But it really sped up the development process. The scripts that we wrote ourselves were for the eye conditions, so how the eye would respond if it had relative afferent pupil disorder or something like that, and also how the pupils would respond whenever a torch was shone in them. So I don't know if anyone's ever used Unity, but I had kind of a wee box collider or a cone collider. Whenever the torch shines up and whenever the collider's in range of the eye, it'll open up if there's nothing blocking it, that kind of thing. So it was a good fun project to work on. I really liked it. Honestly, I think the biggest hurdle or the thing that held up development the most on this was my dumb brain, and I couldn't even understand half these conditions. I had to sit for so long with our client and get him to explain all these eye conditions to me in like complete insane details, because obviously I had to know them in and out to be able to code them properly. So he had to sit for hours explaining them to me and drawing wee pictures and everything. But I got it eventually, so we got to a place where I was happy with it, and it works really well. But yeah, like I said, good fun app to work on. So for our next one, that's you, Cameron. I'll hand over to you here.
Thanks very much, Daniel. Yeah, so this next app is based on construction sites. So obviously they're a potentially dangerous environment. I suppose this application kind of holds a special place in my heart, because this is the first app that I've worked on myself and developed since I've joined the company. So yeah, I'm particularly proud of this one. But yeah, so the application was designed for a client to enable the training and assessment of individuals attempting to gain their initial CSR card. So this card is required as proof of health and safety training competence by many main contractors, clients, and government. So for you to even get access to, physically go on the building site, you're going to need a CSR card. Our application assesses user knowledge through a more interactive and engaging method, and it captures individual performance data in the background, so this can be retrieved by moderators following its use. If you go to the next slide, Dan.
Yeah.
Okay, so the current CSR training method. So currently this sort of training, it's carried out over a 1 to 2 day period, and it's quite conventional, delivered using videos and PowerPoint presentations. So it's not very engaging, a bit of a drag, as you can imagine, and you're most likely not going to retain all of the knowledge that's being conveyed to you. So, I mean, I hate to sort of talk about university again, but that's sort of the closest example I would have, your university lectures, And then obviously at the end, this is assessed through a test at the end of the course's delivery. Next slide, please. So our solution to this, we've created a virtual reality construction site with several different zones within it. Each of these focuses on a different element of health and safety. We also have a central hub as well, which you can see in the picture there, which is kind of like it's kind of like a hub environment that you'll go to the various zones from, and you'll return back here a number of times throughout the application. So the user must work their way through each of the zones, listening to instructions, answering questions, and interacting with objects in attempt to gain score. And users are awarded trophies for each zone based on that achieved score. So you might get bronze, silver, and gold based on the score thresholds. And I mean, this just helps to gamify the application and provide feedback to the user in a more engaging way. Next slide, please. So what issues does this solve? So the application helps to further and cement the knowledge that the user might already have and put it into practice in a more practical way without actually being on a construction site and obviously, facing the risks that come with this. It also increases efficiency as the user has had some prior practical training before going on to a building site, and that places less need on a shadowing process, which then frees up the individual that would have been doing that to carry on with their job. And it replaces the less engaging training method, as I've mentioned, with a more engaging one. And VR training, as we've already discussed, increases retention levels and reaction times. Next slide. Okay, so we have a video here. We have a few for this project, but the first one here focuses on the first zone. The focus here is on health and safety in the workplace, so it's quite general. But you can see there's a couple of objects of interest here. These are actually randomized with each playthrough, so it's unlikely that one user will see the same question set, but each item of interest has its own multiple choice question. So you can see I've got the first one wrong there. But the next item of interest, it says there about material stores on a construction site and why that's important. Once you get the correct answer, you get sound feedback and your score increases, obviously. And as I said, there's 21 potential questions you can get here, but 7 of them will only be displayed on each playthrough. So it's to try and sort of add a bit of replayability, and obviously as well, because we're using this as a form of assessment, it's to make sure that, one person that's being tested, it doesn't get the same questions as the person sitting beside them, and they're able to maybe confer on the answers to questions. So if we move on to the next video. Yeah, that's that one there. So this is zone 2. The focus here again is on health and safety in the workplace, but it's more based on manual handling. So you picking up objects either with your hands or with pieces of machinery. So within this zone, we've got an construction operative standing in front of us here, and you can see he's performing a lift of an object from the ground. So to start this off, we just have a couple of questions, kind of feeding back on what we're seeing. So, he was bending at the knees, his lifting form looked good, so you had to answer a question based on that. And then once we move on to this section, I guess the easiest way to talk about this is comparing it to a matching game. So we have a couple of potential items that you might want to pick up and place in different areas on a construction site scattered around the zone. And for example, the pallet of bricks there, it's kind of, you probably want to lift that with a forklift. So, we've matched it up there. And for each correct item that you match to the appropriate mechanical handling aid, you gain a point. But obviously, if you match the incorrect one, your score doesn't increase. If you move on to the next one, Dan. Yes, so, and then in zone 3, it focuses on health and safety when working at height. So that's maybe whenever I don't know, if you climb a crane or you're climbing to the top of scaffolding, as you can see here. So once you ascend to the top of the ladder, there are various objects that could potentially pose a hazard lying around the top of the scaffold here. And the user gets a checklist in front of them with all of the objects blanked out on it. So it's kind of just, it's up to you to look and try and identify, the potential hazards in the area. So right in front of us here, you can see there's a giant void which you could fall through. So I've identified that, and it's come up on the checklist as an internal void. There's pieces of equipment lying around, that's also a hazard as well. And you gain a point for each of those. And then if you just pause there, Dan, that what you're seeing here, this is the central hub that I mentioned at the start, which is kind of like a workman's hut, or any of those sort of shipping container things you would see on construction sites that people go in and out of. They're kind of like a site office, and you can see there on the whiteboard all the scores for each of the zones. So again, it's giving the learner some feedback, and there's audio as well that plays throughout this experience through the user's walkie-talkie, which sort of will give you feedback. It'll say like, you scored 5 out of 10, maybe you need to brush up on your knowledge, and as well as that, the trophies I mentioned, if you maybe play the video a wee bit more, Dan, you can see them in the locker there just right in front of you, and your hands as well. So for zone 1, the trophy might be the drill. I know zone 3 is the ladder. And zone 2, because of the focus on manual handling, we just decided to change the color of the user's hands, and they can obviously all be interacted with as well. But yeah, like I said, this project, I suppose it's been kind of my baby since I joined the company. It's been, it's something I'm particularly proud of. And the idea with it is, whenever a load of users go through the application and they achieve scores, you should be able to then take the headset away, plug it in, and retrieve the user scores from that, which then the moderators and administrators can feed back to the learners, and they can just get a gauge of where everyone's at with their knowledge and how ready they are and how competent they are in health and safety. So if you move on to the next one. So yeah, again, the technology evolved in its creation. So the application was deployed on the widely popular Oculus Quest 2. So this is a standalone VR headset which runs on Android. So due to this, there's various optimization techniques that we have to use and keep in mind throughout the development process. So for example, we use things like mesh combining and mesh baking light maps. We constantly keep an eye on the amount of draw calls and monitor that and really optimizing materials. And it's just that thing with sort of constantly assessing the trade-off between low poly models. So that's basically lower quality, but greater, that in turn gives you greater performance. So low poly means, I'm not sure if you guys know, but it basically means lower polygons, which everything in Unity is made up of triangles. So the less triangles that are within an object, the less details in it, basically. So we can have loads of low poly models and get greater performance, which in turn will make the experience a lot more comfortable for the user. But that's why sometimes whenever you look at a lot of, for example, even our VR applications, they sort of take on that like anime, cartoony sort of look. Whereas if we put something in place that was extremely high fidelity, like some of the computer games that you see nowadays on some of the really high-end hardware, it wouldn't be comfortable at all for the user. They would probably get motion sick, things like that we really have to keep in mind. So especially on VR, performance is something we really have to emphasize and focus on. But yeah, it's just assessing that trade-off between low poly and great performance and high poly and lower performance. Next slide, please, Dan. Okay, I'll hand back over to Dan for this. This is his project.
Yeah, thanks very much. So a good example of another benefit is the cost effectiveness of immersive training. So this example, we're going to kind of show off how it can be cost effective. NIHE, the Northern Ireland Housing Executive, they're the guys that sort out houses for social housing, that kind of thing. And we're sort of in the final stages of developing an app for them. It's almost ready to go. There's just a few wee changes and bug fixes that need to be done at this point. And the app is actually to train the inspectors that work at NIHE. So the inspectors there, what they do is they would go out to these houses after a resident is finished with it and moving on to wherever next. And they would make sure that those houses are up to a lettable standard. So if there was an issue somewhere, they'd mark it down with a fault code and what needs to be done to address this issue to get it up to scratch, basically. But the way they train at the minute, there's a few issues with it currently. One is that they have to set aside a house and set it aside exclusively for training. So they can't rent that out to other people while they're using it for training. They have to hold that just for themselves, for their own staff, that kind of thing. They only hold the property as well for a short amount of time because obviously they do have to give it up eventually to give it to somebody. And most of the time they take the first available property that's suitable for them. So they might not have the best property that they want. It might not show the best examples to the new staff of what a fault might be. For example, there might be a fault in these houses that usually often appears, and they really want to show that to the new staff to train them up on it. But in this one, the residents might have left it really clean and there isn't much to show. So it could also mean that a new hire is having to wait a long time before they actually get out to a house to do training. So they're waiting about twiddling their thumbs for a while. So you can see there is a few issues with it, but the app that we created resolves a lot of those. So the app that we created, what it does is it creates a VR version. Again, this is the Oculus Quest 2 we're using, so it creates a VR version of a real house. They gave us a house, they set one aside for us for a few weeks for us to go out and scan it and everything, and then we brought that into the virtual world, into our application. And the way it works is the user has to go into this VR house and they have to find faults in it. So you can see in the picture there, above the windowsill, there's missing plaster or missing paint. So that would be an example of a fault. So in the VR app, they'd go up and touch it and we'd ask them, what is the fault code for this? How do you respond to this? And they'd have to pick it correctly. If they get it right, then it'll increase their score and they get more points for it. And the good thing about this is it can be used anywhere. So, they won't have to set aside houses for this. You can have a VR room in the main office and you just tell the new staff to go in and go nuts for a while and get them training on this. And the trainer can see what they're doing and all through it and see their score and everything. It could also be taken home by trainees as well and played at home, or if they have their own VR headset, they could do it on that too. So it's a really good example of how it can be cost effective because they're not having to set aside a house anymore for whatever reason. So I'm going to show you a wee example of the application running here. So this is in the kitchen. This is the kitchen room that we scanned. See, just looking around. So there's the scoreboard with score faults. It tells you all the faults that are in the room. It tells you the faults that have been found. I really like that fault because it kind of shows how, the cool thing about this 6-degree freedom VR and the Oculus Quest 2, you actually have to duck under a table to find a fault, so you actually have to physically move your head and look under things and reach stuff, and it's quite cool like that. And so those are the fault codes down the left, you can see pressing the buttons, and then those are the descriptions of the fault code. So you have to choose which fault code applies best to that. I'm getting them all right because I've done it so many times. If I was to go and do it fresh, I'd probably get so many wrong. But yeah, you can see as well as there's a wee picture comes up too to show an extra detail, you know, anything that you might want to see. We've got teleportation in as well in case, you know, the room that they're doing this in is too small. I think it's really been designed for a 2 by 2, 2 meters by 2 meters room. It's kind of the minimum that you need. But yeah, just sort of teleporting about, and then you can exit the room at any point. Go back to the. I think I missed one there. Yeah, I did, but you can go back and get them or whatever. So this then takes you back to the main menu, and you can select lots of other rooms. So we did the entire house. You know, I think there's about 7 or 8 rooms. I can't remember exactly how many, but I remember it took a long time to scan them all in anyway. So yeah, the tech involved in this part I think is really cool because we used a whole bunch of really interesting technologies for this one. The first bit of interesting tech that we used was finger tracking. So you don't see that in all VR applications. A lot of the time, you know, you'd use controllers, which controllers are good when you need really precise movements, like for ophthalmology, when you're picking up a torch and you have to shine it around. That wouldn't really work too well with finger tracking. You kind of need controllers for that. But the benefit of controllers as well is it's really intuitive. Or sorry, the benefit of finger tracking as well is it's really intuitive for people. You know, they don't have to worry about press the grip button to hold an object or anything like that. They just see a button and intuitively you know to press a button because everyone knows how to press a button. Really, you don't have to worry about holding any controllers in your hands. As well as that, we actually also have a wee training room to get people to grips because there is some bit more complicated interactions than just pressing a button. There's a little pinch you can do to select stuff far away, like if you want to teleport or whatever, or if you want to select a fault that's out of reach, like too high for you or something like that. But anyway, it was really fun to work with the finger tracking on the Oculus Quest 2. Another really cool piece of technology that we used was photogrammetry, which is a really big word. So what photogrammetry is, basically, you're doing a scan of something in the real world, an object or a room, and bringing that into the virtual world. So it's quite a complicated process, especially back when we were doing it a year ago or so, or a couple of years ago. It's actually improved a lot since then. But the way we did it was we stuck chickens, as you can see in the photo there, chickens and lungs and lions and all sorts of weird stuff up on the wall. Hundreds of these. So in every room we had about 100 of these unique image markers, plastered the wall with them. Took ages to set them up and take them down again. And what took even longer was going around and taking all the pictures. So we had a phone camera and a DSLR camera, I think, and we just went around taking hundreds and hundreds of pictures from every conceivable angle and taking videos as well. And then we split those videos up frame by frame. So by the end of it, for just one room, I think we had about 100,000 photos or something insane like that. And then what we do with those photos is we have this piece of software called Reality Capture, and we fire all those photos into this Reality Capture software, and it analyzes them. There's a lot of manual input as well. Like you have to go in yourself and match up and say, oh, this is the chicken marker, this is the lion marker. I can see it in this photo, this photo, this photo, and it then gets all the different perspectives and tries to match up as best it can a sort of a point cloud of the room. So then you end up with a point cloud of the room, and it's not always that good. So the software then, what you do is you have to go and boil that down and create a 3D mesh, which is then 3D meshes, 3 objects is what we use in actual game development. We'll use that for the game. So it then creates a 3D mesh for you, which is very messy. It gets a lot of stuff wrong, and I think the mesh ends up being about 7 or 8 million polygons or something crazy like that. So that is definitely not going to run on mobile hardware. As Karen was talking about earlier, we need low poly stuff for these Oculus Quests because it is really just a mobile chip. It's like a mobile phone. You're basically running this stuff off. So we handed this over to our 3D artist at the time, and she did a really good job on it. She managed to get that mesh of a million or so polygons down to something that was only a few hundred. And it was a really, really simplistic mesh, but it looked great because it still retained the textures that the mesh had from Reality Capture. So you still have the added benefit of these really cool textures on a really simplistic mesh. I'll actually go back. There's a picture of it. So yeah, this picture here, you can kind of see so how one of the walls has only got about 7 or 8 polygons in it, and it still has the cool texture. Like it looks like a real room. Like that looks like a real room, but it isn't. It's a 3D object, as you can see the wireframe over it. I like that picture. I think it's pretty cool. But yeah, I loved working on this project because photogrammetry has always been something that I found really interesting. And if we were to go back and do it now, it'd probably be a lot easier because you can get new iPhones. I think even though they're £1,000 or whatever, but they have LiDAR scanners on them, which is really, really good for capturing and scanning these photogrammetry models and bringing them into the virtual world. So you get a lot better results with that. Whereas I think when we were doing this, a LiDAR scanner would have been something like £20,000 or something wild like that. So we opted just to see how far we got with mobile phones, cameras, and stuff like that. And it still gave us a really good result, I think. But it did take a lot of work on our 3D artist's part to like go in and make those really complex meshes. And it even took a lot of effort on our part as well, just to line everything up in reality capture, you know. But yeah, like I said, really fun project to work on. Some really, really interesting technology behind this, the hand tracking and photogrammetry. Yeah, so it was fun. So to summarize how we want to kind of tie this together, what we're really trying to say is the training room app, I think, is a good demonstration of how you can achieve enhanced focus in immersive reality. You know, they have the headset on, they can't get distracted by other stuff going on Facebook, reading a book or whatever, because they have to watch the video. There's nothing really else they can do at that point. It's kind of like putting blinders on a horse or something like that. Ophthalmology, good for learning on the job, because you know they used to have to go out to students, or they have to go out to patients. Students have to go to patients. They don't have to do that anymore. They just put on a VR headset. Similar thing with construction, but you know, completely risk-free training now. In real construction training, if you fall off scaffolding, you'd have big boo-boos, and in virtual reality, you'd be a little bit motion sick. So it's a good trade-off. And the home inspection app, the one I just showed you there for NIHE, it shows how we can reduce costs in immersive training, because rather than then having to hold aside the entire house and not give that out to somebody for renting, they can just do all the training in their own offices now. So, you know, there is a lot of really good practical benefits to this kind of training. So yeah, I'll hand it over to you, Cameron, for the conclusion there.
Yeah, so sort of following on what you've been talking about, Dan, in conclusion, we can summarize the benefits of extended reality training broadly in 5 statements. So it's experiential. It allows the trainee to immediately put the skills they've been taught into practice. It reduces risk. As Dan said, you know, failure no longer means the loss or damage of expensive equipment, or more importantly, the injury or death of an employee. It reduces travel and training costs, so the trainee can make use of a phone, tablet, or a head-mounted display like a VR headset at a location that suits them, yet still receive the same level of training and service as their colleagues in their headquarters, for example. It results in higher knowledge retention rates, with XR demonstrating 3 times the knowledge retention of conventional training, and as such, it's a much more cost-effective method if results are important. And it results in higher engagement rate, particularly when a head-mounted display is used, as the trainee is isolated from distractions and their entire focus is on the task at hand. Next slide, please. Yeah, so that concludes our presentation, guys. We'd just like to say thanks to you all for watching, and thanks to the System team for having us on. And we'd just like to now open up the opportunity for any questions you might have. I can see there's one already in the chat there.
So yes, so it's about
motion sickness. I don't know if do you want to go ahead with that one, Dan?
I'll take this one. So we actually find motion sickness most of the time. It is not big an issue. There are ways around it now. The biggest one is teleportation, which I think for 99% of our projects we would use. Really, motion sickness kind of occurs whenever there's a difference between what you're seeing and what your body's feeling. So, you know, if you're moving like you would in a traditional game, like smoothly along in the world, in the virtual world, but you're standing still in real life, then you have kind of motion sickness. But with teleportation, when you're moving from point A to point B and instantly teleporting there, it doesn't really make anybody sick. Honestly, there's nobody that we've tested these apps on so far that have got sick. I think nobody that I've sort of had any interaction with. What about you, Cameron?
No.
Yeah, it's been all right so far. Yeah.
Yeah, there's a couple of things to sort of keep in mind. As I've sort of mentioned previously, the target for us is really to achieve a frame rate of 90 frames per second and keep the display at 90 hertz. That really does a lot for, helping to reduce motion sickness and reduce the probability of the learner, the user, feeling uncomfortable throughout the experience. So yeah, if we can keep that display refresh rate high, it seems to do a good job of helping to reduce that.
Yeah, I think that's our time now, 11:44, 1 minute left.
Yeah.
Thank you very much, guys, for listening. I hope you found that interesting.
Yeah, thanks very much, guys.
Right.
Thanks, guys, Cameron and Daniel. I'm always floored by the advancement in its applications and how much of an asset it can be, especially when it comes to things such as training, like you've demonstrated, healthcare, and practically every industry. So, like, my background is predominantly people, and I'll always say, I think it's so funny that I can host events such as these. And I've always been of the mind that, you can't replace the human touch with technology. But you really just got me questioning everything. So should I go back to college now? Should I study VAR? You've got me asking myself a lot of things. However, I do want to extend our thanks for participating in today's system conference as well, and for the amazing presentation. Guys, the attendees, I'm sure they'll be staying back and we'll be able to answer some of your questions. And you guys have shared your social handles so that if they do want to connect with you, they can follow up. So I do want to say thank you very, very much for joining us today and for the amazing presentation.
No problem.
Well, thank you very much for having us. Cheers.
Yeah, thanks for having us, guys.
No problem at all. Well,